now we're going to start module number 4, which deals with muscular system. Now, with the muscular system, as you know, there are different types of muscle tissues. There's skeletal, cardiac, and smooth. This chapter, we're pretty much going to focus solely upon the skeletal part. Not that you can't handle all the other two parts, but you'll pick up the cardiac muscle tissue when you go over the cardiovascular system. Smooth muscle more when you go over, say, gastrointestinal, things like that. But just so we know, in your lab manual, you have a muscle pick list. That muscle pick list is on page 127. Okay, so these are the muscles that you're going to be liable for on your practical. Now, on the practical, keep in mind, let's see, I finished making it up before this fiasco freaking happened. Somewhere around 70 questions, if I remember correctly. The first 30 questions are going to be off of diagrams. The remaining are going to be off of models. The models I already set up, put the tags on them, and said, like, what's this muscle, what's that muscle. It would mean a hell of a lot more to you if you actually could see the models and see them. But again, I tried to make it so it was obvious enough with the correct background so you'd be able to pick it out. But again, the only ones that you'd have to know for a muscle practical would be these here. When I go through the muscles of the body, you understand there's over 600 muscles in the body. No, we're not going through all those. Most of them understand the smaller ones are going to be like in the face, the hands, the feet. Unfortunately, we don't have time to go through all those. We're going to go over the big ones, the ones that you're probably more common, you're more familiar with probably. But again, that's your list. Also, before I forget, on pages 112 to 113, I'm going to say in my lecture just a little bit from now that these are 2 pages that I would strongly suggest you start to look at, to fill in, to preferably, start to memorize. These are the major common muscles that I would expect, wink wink, you to know for an examination. Okay? I guarantee you're going to see it again. 100%. Alright, so with that, the outline I gave you on Canvas has my full outline from my lecture for muscles, so we'll pick it up with there. Alright, so I might as well use these. Now, you see when I start off, I'm looking at my notes. Some of these notes are older than some of you people. Alright, now, the muscular system, again, is over 600 muscles. As you know, the whole point of the muscular system is that this is an excitable tissue, meaning it has the ability to propagate an action potential, a nerve impulse through it. It can't just work on its own. It has to be told to work so that it will actually do its job. Now, muscles, you got to really understand, all the power of a muscle comes from a contraction because that's when the fibers shorten. That's where the power comes from. Nothing comes back from it sliding back into position when it goes to relaxation. So always remember that the muscles can always pull. They don't push, because push is the relaxation phase. Another group of muscles has to work on that. It's all with the pulling toward the middle, where all the power comes from. Now, in the outline, as you see there, I go over, well, the 3 types of muscle tissue you already know. We said we're skeletal, cardiac, and smooth. Again, I'd expect you to know 100% specifically for skeletal that you know it's striated. However, in this module, we're going to talk about why they are striated, why were they light, dark, light, dark. Also, you understand they're going to be voluntary, I hope. Otherwise, you'd be twitching like a mess. Along with that, the skeletal muscle fibers will tire, they're fatigable, and they are multinucleated. If you remember, to be multinucleated, that means several hundred cells, several thousand cells are going to fuse together to make one long cell. Some of the biggest, longest cells in your body are muscle cells. They're only a few, they're only very, very, very thin. I mean, like a few nanometers thin. Think of like a long tube, but they can get up to 30 centimeters long. The longest muscle cells in your body extend from your hip. They go all the way down to your inner thigh to your knee. That's a muscle called the sartorius, and those would be individual cells. But they form because many smaller cells fuse to make one big long one. Well, because they're multinucleated, you can't coordinate cell division with all those number of nuclei, which means there is no cell division. In other words, if you tear it, the only way it's going to fix itself is you're making fibers from one to the other, called fibrosis. your body does the best it can. I told you in class that if you had a choice, break the bone or tear a muscle, you break the bone because the muscle is just not going to heal itself well. You're a candidate for surgery. All right, so coming on down then. I'll give you the functions of muscle. You can read as well as I can. Movement, stability, communication, heat production. So movement, already talked about. That's going to be with in relation to the skeleton, hence why they're skeletal muscles. So as they pull on them, you can have everything from very subtle motion to very large, gross motor motion along with that. As far as stability, that means giving you posture, being able to hold you in the right position. What does that do? It means the bones and the muscles stay in alignment so that whenever you're ready to use them, they're ready to be used and your body can function properly. Communication, nonverbal cues. Somebody winks at you, somebody smiles at you, frowns. Nonverbal communication, that's the way muscles work with that too. I always joke, I mean, if you have a friend, if you're Italian, if I cut your hands off, you wouldn't be able to have a conversation. You just sit there because, you know. Anyway. Heat production, about 85% of your body heat's produced by muscle contractions. Keep in mind, just over your muscles is going to be a layer of fat, and as you know, fat is an insulatory mechanism, so as the body generates heat, the fat prevents it from dissipating too quickly, hence making you a warm-blooded animal. My last one is my favorite one, so you know it can't be right. That is the control of body passageways and openings. We get to get into one of my favorite words, and when we get to anatomy, it's sphincter, because it's just a fun word. I mean, like I said, you can be, right now, you're going through all this stress. As I said the word sphincter, your little mouth just smiled, and you went, hee hee hee, yeah, because it's a fun word. It's like the word booby, hee hee hee, ho ho ho. It's a little bird with blue feet. It's cool. Anyway, but understand, people always think anal sphincter. There's plenty of other sphincters around your body, guys. I mean, let's not focus on one, okay? Give you an example. The one that surrounds your eyes, called the orbicularis oculi. It's a sphincter that allows you to open and close your eye. That's one. Your mouth is called the orbicularis ori. That's how you can pucker. That's another sphincter. I mean, there's tons of these things, but everybody focuses right to the anal one for whatever reason. Anyway, we all know why. All right, so now, whenever you see any of the illustrations which are colored either in a textbook or you see it like on a model, the large bright white areas you see there, that's called fascia. You have fascia that runs down the outside of your leg. The whole idea is so when you squat down and squat up, you basically don't take your quadriceps and blow them out. It's there to hold it in. It's like a connective tissue just holding it in. But that's fascia. All right, next, fossicles. Fossicles, one of the most important terms on this list that we're going over right now. Fossicles are these bundles of proteins. Think of it kind of like a coaxial cable when you have one cable and several other fibers in it. Perfect example to think of what a fossicle is. I'm confident you've all seen or carved or eaten chicken breast or turkey breast. When you cut it a certain way, you'll notice these little tiny fibers come off one at a time. Those are called fossicles. So usually the fossicles are often called the, quote, grain of the meat, meaning the way that the fibers are oriented. The way the fibers are oriented is important because the orientation of the fibers indicates power, meaning where you're pulling from, and also to the extent to which you can pull. All right, next, let's see. Endomysium, paramysium, epimysium. And for this one, you got to suffer through my artwork again. Now, endomysium. First off, you got to understand that, again, the protein fibers that make up the muscle, like coaxial cable. Keep that in your brain, all right? So that means when you have coaxial cable, you're going to have these individual little pieces of protein in them, okay? Now, to make sure that other individual pieces of protein don't touch, rub against them, what do? Think like wires. You've got to insulate each individual little wire. So what you have then is a layer of insulation around each wire. So you'd have numerous of these little holes, little cords running, and each one has its own insulation over it. so that each one does not touch each other. That's going to be called the endomysium, okay? So endomysium means the deepest layer of insulatory material, connective tissue surrounding each one of the individual fibers. The whole point of them is that endomysium, when we go to bigger subjects, like when a nerve comes down in to stimulate them, the nerve has to have an area to attach to. Blood vessels need an area to attach to. The endomysium provides that for each of the fibers. Next one you see there is paramysium. Paramysium, now officially think coaxial cable. I have bunches of these smaller fibers, so what do? I now have a layer of insulation around the bundle this time. That is a paramysium. So the paramysium is going to surround each of the bundles, meaning this surrounds the fossicles. Last but not least is what's called the epimysium. Epimysium surrounds the entire muscle. I'm not going to draw that for you. But that surrounds the entire muscle. You've seen this before. I know you've seen it before. Again, go back to chicken. You're never going to think of chicken or see chicken the same way ever again once I'm done with you. All right, so think of a skinless chicken breast, or you skin the chicken yourself, okay? When you think about it before you cook it, there's this little tiny thin membrane over the meat. That little thin membrane over the meat, that is the epimysium. What is its job? It's to make sure that muscles that occur in groups don't essentially stick to each other, they don't tie around each other, they don't overlap. It's to sort them, pretty much. It's to package each muscle. So therefore, if something happens to one muscle, well, it's packaged and it won't affect nearby other tissues as well, too. That's that one, okay? Now then, therefore, then the epimysium usually then becomes connected to things like, say, your superficial fascia, like say underneath your skin of your face, or to other, it would grade into other areas. Okay, next up, let's see, there when you see I put in the notes that if I have the epimysium, if it degrades into what's called deep fascia or superficial fascia. Deep fascia, the best way to tell it is deep fascia usually doesn't have any adipose tissue, no fat. Superficial fascia, which you already know is called your hypodermis, also called your subcutaneous, that has adipose tissue. So it's just the difference between superficial and deep. One has fat, one doesn't. All right. Now, next, tendons. Tendons, understand, tendons are a form of connective tissue. We already went over. It is a form of tissue where you have layers of collagen running parallel to one another. Tendons are non-conductive tissue. They do not initiate a potential. They do not propagate a potential. They're non-excitable. I said this to you when we went over histology, but think of kind of like a tendon being a bungee cord attaching the muscle to the bone, okay? And therefore, it has no ability to control itself. Basically, the muscle pulling on it will stretch the bungee cord, okay? So therefore, it's going to allow an extension of the epimysium, can extend all the way out, called a tendon, and then grab onto another bone in order for an articulation or a joint movement. Okay, so for tendons you see there, you can have direct attachment or indirect attachment. Indirect attachment is what I just described. When you think of like a muscle that's here and it reaches down to your knee, that's an indirect attachment. Direct attachment means that the connecting fibers are so short that they're actually rubbing against the bones. Perfect example of this, you go out to a barbecue joint, you eat ribs. The ribs are fall off the bone, tender, whatever. The meats fall off the bone tender. That's because those are direct attachment of a connective tissue. So in this case now, the epimysium of what are called your intercostal muscles. Costa is Latin for rib. So these are the muscles in between your ribs. Well, therefore, now you have a direct attachment of the epimysium from those muscles right to the ribs. That's why when you cook them long enough, it basically degrades it and the meat just falls off the bone. Okay? If, however, you have the epimysium extend longer out, that's what we call a tendon. Understand, do not confuse tendon to ligament. Remember, ligament attaches bone to bone. Tendon is where the muscle reaches out to grab to the bone. Okay, going on. Next, what do I got for you? Let's see. Oh, aponeurosis. Okay, aponeurosis. Know this word. You're going to see it again. It's basically a large, broad, flat tendon. So again, if you were to see like the little muscle statues, anywhere you see broad white sheets, those tend to be aponeuroses. Perfect example is your scalp. If you were to get scalped, understand it's just one big tendon, Because you know the bones already. You know this is the frontal bone. Well, the muscle here is called the frontalis. There's a muscle back here called the occipitalis. And as you flex them, you can do things with your face and everything else. That's just pulling. The only thing between them is a large connective tissue, which is the aponeurosis. All right, the next topic you see there is called retinaculum. Retinaculum is a band of connective tissue that underneath it then you're going to have other tendons and other things go underneath it. So think of the retinaculum almost like a bridge, and therefore the other types of tendons will flow underneath like a river. Best example I can give you, think of like a watch band around your wrist. As the watch band goes around the wrist, you are now going to have other tendons go underneath it. All the retinaculum does is it organizes these so they don't, think of them like wires, like puppet strings, and they don't cross over. The best way to study muscles and how they work, imagine you are a puppet and somebody is pulling your strings. Okay, so follow. If I'm the puppeteer and I decide to take these strings and I pull them, my hand comes up. If I'm the puppeteer and I'll take my hand, take these strings and I pull them, my hand comes this way. You are a puppet. However, you manage your own strings. Okay, so just think of it that these individual strings are what are calling each thing to move. That's the best way to really understand how it's going to work. All right, so yay for Pinocchio. All right, so other parts of the muscle. We have three very important terms. Again, you'll see later. The origin, the belly, and the insertion. Okay, so I don't need to draw. So think of a muscle like think of it like a piece of taffy. Okay, the piece of taffy has two ends and the part in the middle. Well, the part in the middle, that's the belly. So whenever you take a muscle and you contract it, it's going to get shorter. That's the part that swells. That's the belly. That's the part that makes the force. Well, then we have the two tips. The origin is going to be that end of the muscle which attaches to a bone, which during the contraction doesn't hardly move at all. However, the insertion is the other end of the muscle, which is attached to another bone, which during the contraction will cause the motion. Perfect example. Your pectoralis major right here, okay? Understand, you're going to have all these little fossicles and pieces of protein, and they have their origin is enormous. It goes all the way down your clavicle, all the way down your sternum, down into your ribs. And each one of these is an origin, and they all insert to just underneath your armpit. So you have all these strings pulling on one little area. What does the pectoralis major do? Well, think. It takes your arm, and it brings it to the middle of your chest. Did your chest move? No. Did your clavicle? No. What moved? Your shoulder moved. It's taking it, and it's pulling it toward it. That's the insertion. This is the origin. Okay. All right. So next. So strength of the muscle, as I said, can go by the arrangement of the fossicles. Okay. There are 5 major arrangements which I listed out for you. So let's briefly go over that. Alrighty. So first one is called fusiform. Fusiform, basically, again, think of like the taffy analogy. Okay, we're going to be fat in the middle and taper at both ends. So that's how the fossicles look. Fat in the middle, taper at both ends. Okay, in terms of contraction, it's not the strongest, not the weakest, it's mediocre. Okay, examples that I cited for you to get you used to the terminology of different types of fusiform muscles, let me remind myself, the biceps brachii and the gastrocnemius. The biceps brachii is this upper part of your arm, so when you flex, that's the one that bulges. That's not the one that lifts your arm. It's actually a helper of the stronger muscle underneath it. But the biceps brachii is this one here. Your gastrocnemius is your calf. That's another example of fusiform. It's fat in the middle, tapers at both ends. Next is parallel. Parallel I'm not going to draw because it's parallel. So what you have are these bands of muscles which are uniform in width, and basically they run parallel to each other. Parallel types of fossicles, they have the ability to contract the most, which means they can also relax the most. Perfect example of it is your rectus abdominis, your abdominal muscles. Because understand, they can contract and they can pull you all the way over and scrunch up to nothing, but then you can also take your hands and you can stretch them all the way back. So these muscles are kind of like an accordion of how much they can actually do this. Problem. Because they have the ability to contract so much and relax so much, overall the power becomes less because you're taking the same power and stretching it out over a longer distance, which is why it's so difficult, to get the six-pack and other things, because it's just you're taking the force over a much bigger distance, and therefore it's more difficult to obtain. Next one I have on your list is convergent. Convergent is fan-shaped. That's what I just showed you before, where I have all these fossicles and they make this fan-shaped arrangement coming to a common point. So if you look at your pectoralis major muscle, it would kind of look like this, where you'd have all these fossicles on one side. That's your origin coming to a common point, the insertion. This type of fossicle arrangement is quite strong. Best analogy I can give you, if you ever think of, you ever watch History Channel and you ever see how they think people made the pyramids. Imagine you have people trying to lift an obelisk, the big, huge, column with the pyramid, with the triangle on top, the pyramid on top. But anyway, enormous. It's heavy. You have one set of people on it with one rope pulling this thing up. Hell no. What do you have? You have this obelisk and you have hundreds, if not thousands, of ropes coming down. So when they all pull at a common point as they pull up, it makes the obelisk come up. That's a much better use of arrangement. So now you have a broader origin coming to a common force point. It's more efficient. Next, pennate. Pennate means feather arrangement. So think of a feather. Feather, you got your quill, and then you're going to have your barbs coming in at an angle, obliquely. Well, there's different types of pennate arrangements. In muscles, this is the tendon. These would be your fossicles coming in. If you only have it coming from one side, that's called unipennate. If you have them coming from both sides, like it looks like a feather, that's bipennate. If you have many of these feather arrangements coming to a common point, that's called multipennate. This one, multipennate, hands down, the strongest arrangement you got in your entire body. Perfect example, your deltoid, your shoulder is that arrangement. It's one of the stronger muscles. That's why when people work out, their shoulders tend to get, very big kind of quick. That's why, because it has a much more ability in order for it to work and actually store protein, get thicker. Other thing too, just the thing that gets under my skin. It's saying people work out and they go, oh, look at me, I'm getting more muscles. I in my brain go, oh, that's nice, but you're stupid. Why? You don't grow more muscles. You have the same number of muscles you had basically whenever you were born. It's just a matter whether they become shorter or the proteins that you're existing became thicker. You don't grow more muscles. So if anybody tells you that to them, just look at them and shake your head and go, that's nice. In other words, okay, you're working out your muscles. How about you work out, your brain? Anyway, so, anywho, along with that then, so for unipennate, perfect example of muscle for that is your palmar interosseous, meaning the muscles in between your metacarpals that actually help you do this, fan your fingers out. For bipennate, you'll see in a couple areas of your body. The one I gave you, I believe, was the rectus femoris. Make sure I did. Yes, rectus femoris. Rectus femoris is your thigh. Your thigh is a quadricep, meaning 4 muscles. You have what's called a vastus intermedius. You have your rectus femoris, your vastus lateralis, and then if I ripped out your rectus femoris, underneath it would be the vastus intermedius, 4 muscles. So you have 1 rectus femoris and 3 vastus muscles, 4. The one that whenever you go, oh, look at that thigh, the meaty part of your thigh, that's your rectus femoris. Okay. All right. Last one you see there, number 5, my favorite, circular muscles, aka, yes, sphincter. So, therefore, where do you see that? As I said, around your eye, the orbicularis oculi, the orbicularis ori. You would have it, say, like for your pyloric sphincter from your esophagus, your esophageal sphincter, your pyloric sphincter. Anywhere where you have a tube where you have to control what's coming and going, you'll have a circular muscle there. Hands down, though, the weakest arrangement of fossicles you have in your body. Okay, next. We can also look at muscles based upon the action they do. Again, these words, you'll see these ones again. You'll see what's called the prime mover, known as the agonist. You'll see the synergist, which is the helper of the agonist. You will then see the antagonist, which is the opposite of the agonist. And then you'll see the fixator. Okay, perfect example I can give you. Imagine you're going to curl a dumbbell. Okay, so we're going to walk you through this. Okay, so the agonist, whenever it's activated, it creates the greatest force during a joint's action. So if just in your brain, hold your arm down to your side. Imagine something's heavy in your hand. What you now do is, in your imagination, start to flex it. Now, when you do that, don't touch the muscle up on top. Touch the muscle underneath it. That muscle underneath it is called the brachialis. This is the one that's actually going to grab the ulna and pull it up. That is the prime mover. That is the agonist. Well, a helper of it is the muscle on top of it, called the biceps brachii. That's a synergist. What's it doing? Think, as I'm raising up my arm, is my elbow moving? No. What the biceps brachii does is it locks the elbow down so you don't get unwanted motion and actually redirects the force of the brachialis. Think, if you're trying to curl something and your elbow's doing this, you can't do it. You have to hold that area down. Now, while the prime mover is flexing, while it's contracting, the muscles in the back have to be relaxing. Those are your triceps brachii. That's the antagonist. So again, think of it like puppet strings. While one string pulls, the other string has to remain relaxed, or my arm's not going to go anywhere if they both pull. It'll just sit there. Okay? Usually whenever you have an agonist, you have an antagonist. That's called an antagonistic pair. Again, think of puppet strings. The last set are called the fixators. Fixators are muscles outside of where the joint action's occurring, and they basically stabilize other areas to make sure you don't get unwanted motion. The ones that you have when you're curling your dumbbell, your pectoralis major in the front, and then you also have your rhomboideus major and minor in the back. Your rhomboid major and minor go from where your vertebrae are over to where the flat part of your scapula is. Again, it looks like a diamond, and what they do is whenever you flex, you feel your shoulder lock into place. Well, that's because your pectoralis major locked down in front, the rhomboid's locked down in back. Now what happens is your shoulder doesn't roll, because if you try to curl something and your shoulder is rolling, you can't do that either. All right, hopefully that made sense. Okay, let's see, next. Intrinsic versus extrinsic muscles. Intrinsic muscles, it's kind of a unique descriptor. It means that the origin and the insertion of the muscle are pretty much in the exact same location. Like they're side by side. This is only going to be used for very unique muscles around your body, meaning you're not going to hear it really from me again. Things like your tongue, things like your larynx. Your larynx is your voice box. You'd also see it in the deeper muscles of your back, muscles of your hand and your foot. Extrinsic is more what you're used to thinking of, where the muscle is one place, but it's going to actually cause a motion somewhere else. Here, real simple. Take your arm, and what you're going to do is you're going to put your fingers on your wrist, okay? Now, what you then do is take your hand and you just pull it towards your face. What you'll do is, if I take this, put it on your wrist, slide it up to your forearm. If I take my hand and bring it to my face, you'll feel these muscles start to contract. That's because they're doing the work. These are called flexors. Well, if I want to extend my hand, take your fingers, put it on the back of your arm, and pull it away from your face. And they're pulling at that time. The muscles are here, but they're acting on this area up here. The origin and the insertion are not in the same place. You want to creep yourself out? Real simple. Take your hand, put it on the wrist, and then just bring your middle finger back. You'll feel the one cord. You can see mine moving. Then go to the next one, your ring finger, and basically proving to yourself you're a puppet. Okay? These are individual strings. Okay. Now, let's see. Next topic is called muscle innervation. Innervation is the fancy word to say how a nerve comes into a tissue in order for it to excite it, to actually activate it. So anytime you see the word innervation, it's a very generic word. It just means how the nerve gets in, which we'll go into at a later lecture when I go over what's called the excitation coupling. I mean, it's a lot of biochemistry and it's a lot of molecular, and I'm going to be using the whiteboard, and God, I hope it looks somewhat okay. It's going to be, I'm pretty sure it's going to look like a murder scene, but we'll see. All right, but I'll do the best I can. Now, you see there, though, understand that the main conduit for nervous tissue for you is your spinal cord. You got that, okay. Now think. You got your skull. Underneath your skull, you got your foramen magnum, okay? That foramen magnum has holes on either side of it too, and you remember other holes like the foramen ovale. You remember the foramen spinatum, all those, okay? Those are all holes. We got that. All right, fine. What do those do? Those are nerves that are going to come out of the foramen magnum and come out underneath the base of your head and go to your jaw and go to your face. So therefore, what's going to operate the muscles of your face? They're not your spinal cord. They're nerves coming out of the foramen magnum to your face. Those are called cranial nerves. Nerves that are going to be able for you to move your fingers, wiggle your toes, move your legs, raise your arm, raise your thorax. Those come from your spine. And if you remember, when you take two vertebrae and you stack them on the top of one another, there's a little hole in between them called the intervertebral foramen. What comes out of those are now spinal nerves. Spinal nerves are what let you talk to the rest of your body. So cranial nerves are designed for basically to talk to your face, electrochemically, and also your neck. Once we go beyond that, now we're going to have the spinal nerves, where the spinal nerves come from your spinal cord, go out through the vertebral foramen, and reach out to the muscles in order to make them work voluntarily. Okay. All right. Next, naming muscles. Okay. So, naming muscles themselves. Trying to think. My notes that I wrote for myself out, eons ago, I didn't write them all out for myself because basically I just wrote them out, and then in class I would look at them and tell you what it is. Real simple. What I'm teaching you is a little bit of Latin so that you understand what it's trying to say. Again, I don't have the list in front of me. I wish I had a printout of it, but I don't, and that was short-sighted on me. However, just understand that it's nothing to memorize. It's just basically telling you the name and what it means, in generation. Give you an example. We can go by comparison. If I have major means you're comparing two muscles. Major means the larger of two. Minor means the smaller of two. If you use the word maximus means that it's the biggest of three or more muscles. Minimus means the smallest of three or more muscles. Example, think gluteus maximus. Here, back up a little bit. You back up a little bit. All right, well, here, you're going to see my butt then. All right, so gluteus maximus, that's the big one. Above it is the gluteus medius. If I were to rip your butt off, underneath it is the gluteus minimus. Three muscles, meaning largest, middle. Okay? All right. Other things. Let's see. Like I have in there, you have longus and brevis. The longer of two, the shorter of two. You can also have, superficial versus deeper. So you would have, brain fart now, superficialis to, oh my god, brain fart with deep. Superficialis, it'll come to me, sorry. Anyway, you can also go by the shape of the muscle as well too. If the muscle is triangular, okay, if the muscle is like a diamond, that's rhomboideus. If it looks like a trapezius, a trapezoid, think of like a triangle with the top cut off. That's called a trapezius. You can think teres. Teres means in a chord like a cylinder or round. Then let's see, we can go down into then where it's located. The located ones you should be the most familiar with. Like if I say cervicius, that means of the neck. Capitis means of the head. Femoris, of the femur. I mean, it just abdominal tells you, where it is. Lumborium is in the back. Those, you basically it's just to give you a guide so you know kind of where to expect them. The beautiful thing about muscles is that the names are so long is because they try to describe the muscle in Latin, basically to its shape, its size, where it goes, what it does. So if you know a little bit of Latin, it's easy because it's telling you, I am the muscle that goes here and does this and does that. Like if you say pectoralis major, pectoral, it's on your chest. Then major is the biggest of two. Well, if I have the pectoralis major, if I rip that off, underneath it, I have the pectoralis minor. If I have a major, I got to have a minor. That's just how it works. But again, just look at those terms, and please, you don't have to memorize them, just be familiar with them. All right. So, let me go over the characteristics of tissue. And then once we kick this up again, I'll go over the microscopic anatomy of a muscle cell. That way this isn't too long. All right? So, the characteristics of muscle tissue, again, you can read there like I have. Again, nothing to memorize there, just in generalization. Muscles have to be what we call excitable. They're responsive, meaning they have to have the ability to respond to a stimulus and conduct and actually be able to respond to a stimulus and move an action potential, a nerve impulse. Number two, they have to be conductive. It means once they're initiated, they can propagate it throughout the entire tissue like a wire. They have to be contractile. Contractile is what I said is where all the power comes from, where you shrink. Well, whenever you shrink, you also then have to go back to your original shape. That term is going to be called then, that's going to be the elasticity. Elasticity is going back to the original shape prior to the contraction without damage. Now, if you work out, well, before you work out, what should you do? You should stretch. Stretching muscles is called extensibility. Extensibility means the ability to stretch it to a point where you're not going to damage it, but then it can come back to its original shape. Understand how muscles are. Muscles are kind of like they're more or less voluntary bungee cords, that you can control. You can control them contracting and coming apart. Well, your liver is not extensible. I can't take your liver and go, stretch it. It's going to rip. If I take your lungs, it's extensible, but to a point. But if I keep pulling it, it's going to rip. So muscles have the great ability to have that kind of, accordion ability. Okay? So when we come back next, I'll go over the anatomy of a muscle cell, and then go over why there are dark lines, light lines, and that's when I'm going to start my really bad artwork. Also, then I'm going to go over the muscles of the body that you're going to have to be liable for, like on the statue, meaning the little Mr. Man statue, and then also the arm and the leg, which means I'll give you the pages out of your manual. Remember, your manual is your guide. Those are the muscles that you have to know, like on a model, that tells you, for the leg, know this, for the arm, know this, for the little man, know this. Okay? So, see you in a bit.